Perfect. Thanks for the intro. Hi, everybody. Really glad to be here. I'm joining you from Amsterdam, the Netherlands. That's where I live. It's currently 8 o'clock at night over here. Background behind me is not what it actually looks like, but seem to suit the nighttime delivery. Today, I want to share a bit about my background, experience, and the types of roles that I had throughout my career at specifically at Intel, um, and share some of that experience and training that I had, and then review a case study, which is maybe a non-traditional type of engineering application, but especially as industrial engineer, process engineer, systems engineer, this may be a type of challenge that you see, and then share a couple learnings that I had from that case study or things that I brought to it that have been important throughout my career. If you have questions, I'm going to reserve time at the end. If you've got something that's really relevant to the slide that we're looking at, please jump in. Dr. Mahoney, I don't know if you have a protocol for how you want to manage that.
So I actually haven't done a virtual one of these before. There is a Q&A like button at the bottom. I've not used it, but that might be a good way if you slot it in there, and that way when there's like a natural break, we could see if there's a relevant Q&A.
Perfect.
Otherwise,
Perfect.
a hand
So
raise is
yeah,
probably fine. A virtual hand raise.
if it's specific to the slide, let's try to take it in at the time it comes up. Okay, so let me talk a bit about my engineering training. So, when I was in high school, I went to Engineering Week that was hosted at Lehigh University, and I went to check out a few different types of engineering. And at that event, industrial engineering really sparked something in me. It was being able to combine a bunch of different skills and bring together and integrate different aspects of specifically focused on manufacturing, or at least that's where I thought my career was headed at the time. And I thought there was a large variety of problems and interactions with a lot of different people and disciplines that really sparked my interest. And so I really only looked at schools that offered industrial engineering and ended up at Penn State. I got my bachelor's in industrial engineering, and then when I graduated, they started a brand new program called QMM, Quality and Manufacturing Management. And so I stayed on for an extra year for the first year of that program to get a master's of manufacturing management. And for me, that's been really beneficial. Some of the topics that we discussed there have been relevant to me throughout my career. And so that's been a really good combination to get a bit of the flavor of what's important to the business with a strong technical background has helped me to balance those factors throughout my career. I'll also say, beyond the education, getting experience along the way is something that I really value and was really important, building up to and helping me get hired for the full-time role that I had that I'll talk about on the next slide. I had three pretty different experiences at Air Products. I worked in their management information systems, or what today is typically called IT department, working on databases. I actually moved out to San Francisco to work for Schlage Lock Company and work in the quality department on their high-end lock line. Learned a lot about traditional manufacturing, about statistics and quality during that summer. And then in the summer between my graduation and starting the master's program, I worked for W.L. Gore and Associates in Delaware. And that was sort of a bridge between manufacturing and supported the logistics and packaging operations there as well, which eventually eventually helped me out in my long-term career. So if you have the opportunity to intern, co-op, definitely recommend one or more chances to get a feel for what you like, what you don't like, the type of corporate environment. There's nothing that can really compare to that as you prepare yourself for the next steps after your graduation. In terms of certifications that helped me along the way, I would say this first one, obviously very specific. You'll see in the case study and in my career experience. I didn't end up going into manufacturing, although there's plenty of manufacturing to be done at Intel. I immediately went into the supply chain group and specifically logistics and getting further certifications because my education at Penn State was not focused on supply chain. Getting additional training once I joined the workforce was extremely helpful. This certified supply chain professional or CSCP really has helped me to get a more strategic view of the supply chain and help me to grow through the roles that I'll show on the next slide. Lean Six Sigma and various improvement methodologies are something that's very valuable to give a structured methodology to the way that you approach problem solving. I'll talk also about theory of constraints, which is a methodology that I really adhere to. I'll talk about that in the case study. So those type of structured methodologies help you not only to approach problem solving in a specific way, but also if multiple people on the team have that background, you have sort of a common terminology to help you think about the problem, to communicate with each other, and really speed your way to solutions. Um, Intel Supply Chain Masters. So this was a recognition that I got at Intel to really acknowledge the results that I brought to the organization and the expertise that I developed over my years working in logistics. So specifically within the discipline of logistics, but throughout my career, I had the opportunity to partner and orchestrate across different aspects of the supply chain. I'll show that on the next slide. And early on in my career, I had the opportunity to go out to Georgia Tech and take a very specific course in warehouse and distribution center layout. And that was extremely helpful, not coming from a logistics focus in my education to immediately jump in and have an impact in my first role, which I'll talk about right on the next slide. As Dr. Mahoney mentioned, I was at Intel for 27 years from 1997. I took an early retirement in that started in March of this year. I don't know if that'll be a permanent retirement. I'm probably looking for additional roles, but at the moment, I'm flying solo. But when I started with Intel, I began as a logistics project engineer, and that at the time was extremely focused on expanding the amount of storage and processing capacity that we had to handle increasing volumes, both the size of chips as well as the amount of chips that we were selling. I joined Intel at the time of Pentium 2. And it was a big surprise for the logistics group when they opened the first box of Pentium 2 processors, where traditionally they had been dealing with a standard format of a chip. They had decided to make a significant shift to a different format, which looked more like a Super Nintendo cartridge, if you're familiar with that. It was a significantly bigger form factor. It required a lot more storage, and so a number of industrial engineers came into Intel at that time to start growing the footprint of logistics and distribution, both next to our factories where we needed it, as well as closer to our customers. I'll talk about that a bit more in the case study. So really, initially coming in as a logistics project engineer expectation was to design warehouses. I had a budget to do the layout of the warehouse, as well as to purchase and install all of the equipment that was needed in that warehouse. So even coming in at entry level, had a pretty decent budget and a lot of autonomy and a need to work across many stakeholders, both those that were designing the processes, those that were designing the systems that would run in those warehouses, and most importantly, the operational teams that would have to run those warehouses and make sure that the layout and the design and the equipment were going to work for them for the long term. And we didn't get everything right, but several of those warehouses are running with a pretty similar equipment set and layout and flow to what we started to put in place when I started there. So I think we did a pretty good job. As I moved on a few years later, I became a manager of the industrial engineering team. That meant being accountable for continuing to expand the capacity and get designs for additional warehouses that were coming on board at that time as we continued to grow our footprint worldwide. And also to make sure that the performance of those facilities was as optimized as possible. There was a big focus on cost, and one thing that I really wanted to put my stamp on as an IE manager was to not only focus on cost, but also look at the flow, how we supported the revenue of the business, the cycle time, and you'll see that come through in the case study that we talk about today. Because especially in this business, logistics was not the overall limiter of doing business, and there was supporting the revenue had a much bigger impact on the business than just trying to minimize the cost and efficiency of the operations that we ran. So that was a focus of mine as I moved into that engineering manager role. Uh, Beyond that, I moved into a role called technical program manager. And this was an opportunity for me to use the knowledge I built within logistics and partner with other aspects of the supply chain. The first program that I did, for example, was implementing unit level traceability. So historically, we had managed at the batch level or the box level. And there was a need in the industry and specifically at Intel to actually trace each individual chip. And so that meant that we needed to partner with manufacturing and implement that capability into our warehouses so that we could track the chips all the way from the start of manufacturing through to the customers, so we knew where those chips were going. And then there were several other projects, including the case study that I did, which was a strong partnership with sales. And later we looked at increasing our forward stage distribution, which was a partnership with planning. So I sort of built on my early career of building that expertise in logistics and then extended that to basically represent logistics and partner with other groups to develop broader capabilities as a technical PM. The next item there, warehouse operations manager. So this was quite helpful for me because I took sort of a pause from doing that technical program management between some of the programs that I just mentioned, and I actually had an opportunity to run a portion of the warehouse for a year as the operations manager responsible for all of the day-to-day operations, the overall revenue, the performance and quality to our customers. And this really, I say that it gave me much needed street credibility. So throughout my career, I was building capabilities that were used by the operations. I was not directly responsible for executing against those capabilities. So by getting in there and running the operation, it gave me a platform to speak with other operations managers having been through many of the same challenges that they had been through. And as I brought solutions forward, it helped to engage in that discussion because I had seen similar challenges and it gave me a more realistic view of the challenges that they were facing and a way to talk to them on their terms about how the solutions could help them to resolve those problems. After that, and a bit more time as a technical PM, I became the logistics systems strategy manager, basically as someone interested in the process of logistics. Much of that process is tied up in the ERP, the Enterprise Resource Manager, which we used SAP at Intel. And so being able to manage the performance and the process really required designing the way that we implemented our processes in the system, SAP, and other complementary systems. And then the most recent role that I had was as a senior logistics business architect. And this was really just extending and acknowledging that the integration of the process, the system, uh, the equipment, all of those pieces came together to generate business output and business outcomes. And as a business architect, my role was to look at the interaction of all those pieces across our logistics operation, as well as interacting with our upstream and downstream partners and making sure that we were building solutions that were holistic and really delivered the optimal business results. So it gave me a bit more responsibility to look across the all of the aspects of logistics and make recommendations about how we strategically position ourselves to get the best business results. And the shirt that I'm wearing today, this is TMS. This is one of the last projects that I was an architect on. This is our transportation management system. So when we talk about logistics, it's really the movement and storage and delivery of all of the raw materials, all the movement of goods between different aspects of the or different factories and warehouses in the supply chain, and then eventually the delivery to customers. So both the warehousing and the transformation and the transportation. I'm going to switch into the business scenario so that we have enough time to go through that. So basically, we're going to talk about, sorry, I want to make sure that I have a clear time check over here. Okay. Uh, this is a scenario where we're talking about the distribution of finished goods that go from our factory and regional warehouses. So we assembled these chips, let's say Pentium 2, Pentium 3, now the Core series that Intel has at various locations around the world, and our customers were based around the world as well. And so we needed to store these chips when they came out of the factory and then distribute them to the customers. The customers that we were dealing with, OEM, original equipment manufacturers, these are companies like Dell, HP, Lenovo, Apple, that were consuming these chips into their laptops and desktops and servers as well. And we also had distributors, and the distributors were selling chips direct to customers. So many people build their own desktop PCs, and you buy the chips through distributors. And distributors also served some of the smaller customers or local PC shops that we had around the world. To get from our warehouses to the customers, it took between 1 to 5 days, depending on where we were shipping from and where the customers were located. I'd say the average was between about 2 and 3 to get from the warehouse to the customer. And at the time, our customers had to place orders 90 days in advance. That sounds like a lot. The manufacturing process, the process to make or fully fabricate a wafer, can take between 13 and 26 weeks, depending on the complexity of that. It is possible to make them go faster, but typically it's taking about 90 days. And so getting a firm commitment from the customer about what they needed helped to make sure that we weren't putting things in process that weren't going to be sold, because it took a long time to change the direction of the plan because if we needed to introduce something totally new, it was going to take 90 days until we got it into assembly and ready for distribution. What we found with this existing or this baseline process was that customers, even though they put their orders in 90 days in advance, they were changing the details of that order, the quantity, the specific SKU that they wanted, the specific product type, maybe the address where they wanted it delivered, or the date, the specific date when they wanted it. They were changing that on average 24 times before we actually shipped it. And so uh, that among other changes in the industry and the expectations of customers led us to look at a business transformation, right? And the business transformation, I won't address the first three; those basically stayed the same. But the transformation was that we told customers that they could order when demand is firm, basically moving from months, 3 months, sometimes more, down to days when they could order. And instead of having them put a firm order in the system, we would do collaborative forecasting. So basically, we would partner with them. We would ask them, how much do you think you'll need? We would negotiate back and forth, but we didn't require them to put firm orders in place that we would have to have a lot of administration and rework on dealing with all the changes they had as it got closer to the time when they would actually build the laptops and desktops that they were going to deliver to their customers. So these were the two big changes that we were having across the entire supply chain, and logistics was just one piece. Obviously, the sales group was relying on these orders to run their activities. The planning group was using the orders as what they hoped was a firm commitment of what the customers wanted, but obviously that changed a lot. So all of these groups in the supply chain were going through a transformation. I'm going to speak to what it meant for logistics and how we dealt with that. Do we have any questions? Anything in the queue? Okay, sounds like not yet. Oh wait, I see some things in the chat. Let me just look to okay, nothing new. So basically, this transformation that we were going through created a conflict, right? So from an industry perspective, what our customers were expecting was more speed. Now, coming at the end of the 2000s, and really this was changing across all industries and continues to change. The customers were getting more and more more and more of the power in the dynamic between customers and suppliers. This was the rise of Amazon, the growth of Walmart, and customers, like let's say end customers, were expecting that they could order today and get something the next day or maybe within 2 or 3 days. Those type of trends were also happening and continue to happen and maybe even accelerate in the business to business world as well. And so there was an increasing demand for speed so that they could wait until the last minute to see what their customers. So if we're talking about Dell, HP, Lenovo, they want to know what their customers want before they commit to what chips they're going to put into the laptops that they plan to sell. So they want faster delivery, shorter lead times to be able to do that. That, of course, is not necessarily free. So doing things faster comes at a cost. At this time, we didn't have all of the infrastructure in place that enables what happens today with Amazon Prime. Those things were still growing. But as you speed up and you get less time to react, then that can inherently bring more cost into the equation. And this is our warehouse getting squeezed in the middle between the demands of the system that wants more speed and the need from the logistics team and from Intel in general to avoid their costs spiraling out of control and to protect their profit margins, which is one of the things that the engineers are responsible to help do. So this was really at the heart of the conflict that we had. How do we get faster without dramatically impacting the cost? And and so we really took a look at what does our system look like. Now I'm not gonna dive way into this chart, but I wanted to give you an example because this is I think one of the key items that I'll touch on at the end is the importance of looking at the data. And what this represents is the number of orders that we saw from our customers on each day of the week. So each point that you see here is one day. The y-axis is the number of orders that the warehouse was expected to ship on that day or when it needed to ship to meet the customer due date. Um, and and yeah, each day is basically, or each point is one day. So this is a distribution of days, probably about a year. This looks like about 50 points for each of these. That's probably what we looked at the time. And this was the variability of what happened on different days. Anybody have any observations about what this looks like if you have to run this operation? I don't know if we anybody wants to come off or put something in the chat. I see somebody clicking. Okay, not seeing any responses yet, so I'll keep it moving. Um, you know, from the warehouse view, this was extremely variable, right? And what we called it in the warehouse world was high nonlinearity. So in the ideal world, we get the same number of orders to ship every day. But because our customers are placing the orders, we're not just planning for how we're going to meet the demand in advance. When our customers place their orders, they tell us what day they want it. And so based on that, it creates a lot of variability. This creates lots of challenges for the operations, primarily that they either need higher capacity. So when we talk about capacity, this is picking picking boxes off the shelf and packing them and preparing them to ship to the customer and then handing them over to a transportation provider who will deliver them. So from a warehouse perspective, it's primarily about picking and packing. These are labor intensive operations to get those done. And if you have to do more picking and packing on one day, so for example, you could see Friday, this is the peak. This was the average for Friday, well above the other days. That means that you have to have more capacity in place, and that capacity is not free. And we'll talk about that as we get further into the case study. On the flip side, if you don't put the right capacity in place, your customers are going to notice. They're not going to get the orders on the day when they want them. We call that on-time delivery or delivery performance. And it really wasn't an option for us in the logistics group as we went through and supported this transformation. It wasn't really an option for us to make the customer experience worse because we wanted to keep them happy and purchasing as many Intel processors as we could. So this is where we started. This was really what it looked like from the warehouse, and now we were introducing this new factor of trying to do this faster. So if I kind of simplify this graph into a bar chart, sorry, I wanted to mention one thing on this just to get specific on the chart here. This is called a box and whisker plot. When you get into your stats classes, you'll probably see this. I find this is a very useful type of way of viewing the data to break things into categories, whether it's time, you know, by day of week, by different types of products, by locations. It really helps. It really helps you to see where there are differences, which you can then look into why do those differences exist as you try to solve the problem. Okay, so when we look at how are we going to solve the problem, we first look at how are they doing it today. So in the original scenario, customers were booking 90 days in advance, so we knew what they wanted and when they wanted it. The warehouse was allowed to ship ahead of the date, the commit date when we said we would send it to the customer. So we had agreements with the customers that said we could order, depending on the customer, 1, 2, 3, or even 5 days ahead of the commit date. And we would download the orders. That means we would bring it in and be able to start the work in the warehouse in advance. And in this case, it was up to 7 days in advance. So I said I would simplify that previous chart. So basically, these are like the averages of what we saw on different days of the week. And this is the way that the customer orders were coming in. Now, I talked a bit about capacity. Installed capacity basically means how many orders can we actually pick, pack, and ship per day. And so this basically represents the red line. If we're above that line, we're going to miss some of these orders unless we introduce extraordinary measures like overtime, and then you start to impact your cost, which is something that we're trying to avoid. So, what we did, or what the warehouse did, was they created a work plan. So, looking up here, I had the orders in advance. The warehouse was allowed to ship ahead of the commit date. So, I could basically take these orders that were above the line on Thursday and Friday, and I can time shift them and move them to Monday, Tuesday, or Wednesday so that they fit within the installed capacity of the warehouse. That is how we ran the business to be able to keep a relatively level amount and a reasonable amount of capacity, but also handle that variability that we saw on the previous slide. And the fact um, that we had advance notice on that allowed us to be very effective at creating this plan. And when I talked about linearity on the last one, you could see we generated a pretty decent linearity. It definitely wasn't this perfect, but this is just a simplification. But we were able to manage and ship within the capacity that we had and get a good balance between the customer experience and the costs that it took to deliver that experience. So this was the baseline. So now we get this new scenario coming at us. Basically, the customer was allowed to do quick turns. That basically meant they could call on a Monday morning, and we would ship it by Monday afternoon. So that was a big change. We saw some of those as an exception, but this was expected to potentially become the norm. Also, I mentioned that we were allowed to ship 1, 2, 3, or even 5 days in advance. Customers were indicating that they wanted a smaller ship ahead window from us so that they would hold less inventory. If the shipments got to their facility early, they needed to find somewhere to store that, and that meant they needed more storage space. It also meant that the inventory that they got went on their books and had to be reported in their financials, which isn't always positive. So the customers wanted to give less flexibility to us, and that meant that we would be downloading the orders later, closer to when they needed to ship, and so the warehouse would have less lead time and less flexibility for being able to ship. So to look at that graphically, the customer orders didn't really change, right? So they were still coming in about the same pattern when the customers needed them didn't change, but how much opportunity we would have to react to that was changing. So essentially, our warehouse work plan, when faced with this, we were going to have spikes that we really were not able to deal with. So you could see Monday and Tuesday would look good. Thursday and Friday we could bring down a bit, but we were going to exceed the amount of installed capacity we had. So this is when I had that first slide that talked about the trade-off between speed and cost. This is really where the rubber meets the road. We had less time to work on the orders, but the volume of the orders stayed the same. We weren't able to take orders from Thursday or Friday and move them into Monday or Tuesday, and therefore that meant that we needed some solutions to figure out how to resolve this. So, moving ahead, the most obvious solution and what all of our models told us to do with this because that was a big piece of industrial engineering was basically capacity planning. How much labor and equipment and storage would we need to be able to handle the future scenario? So when we changed the parameters of the model to say that we weren't going to be able to smooth out the demand as much as we had in the past, the answer of the models was, hey, put in more capacity, right? So that was sort of the obvious solution. The downside of that is that that was going to come with significant additional cost. We needed to hire more labor to be able to handle this new peak of capacity. We also would need more capital equipment to be able to handle the flow on those peak days. And we would probably need more storage space or staging space waiting for the trucks on those days as well. In some cases, our warehouses were actually that would exceed the footprint of the warehouses that existed, which really caused would cause some challenges for us to be able to address it in this way. So this was kind of the first path that we looked at. You know, we need to go do this. They're changing the business model. The business model adds more stress, so therefore we need to put more capacity in place to relieve the stress. The second one that we thought about was going to our customers and asking them to change the way that they order. If the incoming order pattern that we're looking at here wasn't so spiky on different days, then we could keep our installed capacity the same. I think I have that here. So basically, the blue line would change. We say, customers, can you order more on Monday, Tuesday, Wednesday instead of Thursday, Friday? This was not a popular option with our partners in the sales department because their job is tough enough to get the customers to place orders and increase the amount of orders that they're placing and sell through the Intel inside message that we were trying to generate. And so going to the customers who were currently happy with the way that we did things, it was going to turn them into grumpy customers. And that was not really a scenario that the sales department wanted to deal with. So we went back and we looked at the data again. So this chart that I'm showing you is basically a set of time series. So the bottom of the chart is the different days in chronological order, and these are the orders that are coming in. And instead of just looking at the pattern that the customers had, we said, okay, what does this look like at each step of the process as we go through the warehouse? And does anybody see any patterns, or does anything stand out as you look at these charts? Do you notice anything? And let's just see how I can get feedback. Okay, we got a shy group today. I'll warm you up for the Q&A at the end then. So what stands out here is basically that the order scheduling, and this was our own internal process, was adding a significant amount of variability into the order pattern. So the blue lines that we looked at before, this is what the customer was asking us to do on every given day. And the way that our system was configured, they would request, this is when I want it delivered, and our system would come back and say, this is when we can commit to deliver. And you could see it's significantly more variable or spikier than the input that we were getting from the customers. And these two down here, these are the green lines that I showed on the previous slides. Our warehouse team was having to do a lot of work to move orders from the end of the week towards the beginning of the week. But the fact is, they actually did a really good job of that, right? But the challenge is we were going to make their job a lot harder. We were going to change the rules and give them less flexibility. And so their ability to do this was going to get harder and harder. So as we dug into the data a bit more and we looked through trying to create additional options of how we could solve the problem without adding cost or upsetting the customers, we focused in on this area where we were adding more variability into the process and trying to figure out why was that happening. So basically, as we looked into that, we found that we had put, I mentioned earlier when I talked about my different roles, uh, the ERP, the system that is running the business and the way that we run our processes from taking the order to scheduling it, responding to the customer, and even executing the shipment, we had put rules and parameters that were embedded into the system that were causing that variability. The specific rules that we had in place was, although we were running a 7 day operation for the warehouse that I'm pointing out right here, we had told the system that we only worked Monday to Friday. And so we were actually blocking the scheduling of orders on Saturday and Sunday. Now, the warehouse operations team had requested this because it gave them a lot of flexibility to manage their workforce, to use the warehouse planning process that they were very good at to basically cherry pick which orders they were going to do on which day. Now, under the original scenario, that was actually working pretty well. But under the new scenario, they were going to have less flexibility. So we had to go and look at what are the rules that we have in place and challenge those. And when I talked through the themes, this is something I'll come back to. Uh, it's easy. I won't say it's easy, but it's straightforward to look at capability changes. If you want to add more labor, if you want to incrementally add more processes, if you want to add more storage, those are things that you can calculate and you can look, and your models will tell you that those are solutions that can solve your problem and give you additional capacity. The policy changes, I think, are more powerful, both in the way that they can impact and also the uh, less negative effects. In this case, primarily the cost, which I'll show you in our results. So we had to look within the policies and the way that we had told the system to drive our processes and really change the rules that we put in place. We were also able to go and talk to our sales partners, and we said, hey, instead of going from 90 days to 0 days, like that's really amazing for the customer, but that could be very expensive for us. If we get 0 days, there's really almost nothing we can do to shift the volume from one day to another, and therefore we're going to be stuck increasing our capacity. So, would it be possible for us to set a rule instead of 90 days going to 0? Could we start with 3 days, right? Because when you offer new capabilities or services to customers, one rule that is true, and you probably know it of yourself, is that you really don't want to back off to a worse level of service, right? So if we had told the customers you can have it the next day or order today, ship today as a general rule, if we went back later and said, hey, that's not really working for our warehouses, we need 2 or 3 days, they were really not going to be happy. We're going the other way and saying we're going from 90 to 3. Well, that's like, that's a 95% improvement in the lead time. And we committed that we would try to get that down to 2 days, 1 day, or even 0 days, as well as providing some exceptions. We also had to talk to the factory to make sure that we could have exceptions when there were critical orders that were coming out. And we looked at how we synchronized the timing and maybe the batch sizes of how we did work so we could get a more linear flow of work through our warehouse. So this was really where we made some changes. The biggest one that I said was just going in and looking at, hey, what policies do we have in place? These policies had made us successful over the previous decade and able to have a very efficient and on-time warehouse. But in the new business conditions, they actually made the performance significantly worse. So we had to have a lot of discussions, and this is where the technical skills meet the soft skills. We had a clear recommendation of what we wanted to go do, but having the discussion and convincing operations that this would work in their favor when for the previous decade, the rules that they had in place had made them very successful and effective. Those are difficult discussions to go and convince them that making these sort of policy changes are going to be beneficial for them and for the company in the long run. It's much easier for them to see that, hey, if we're changing the rules, then just give me more capacity because that's how we respond to volume increases every other day. So why would we change that? So some challenging discussions to go through this. We used data, we used simulation, we used smaller scale pilots to increase the comfort level of the operation with the changes that we were going to make. And basically, what we did was we went from our 5-day rules. Here we changed it and we opened up Saturday. Here we changed it, we opened up Sunday, and we actually linearized if that's a real verb. We linearized the distribution of orders as we got to opening up the parameters and making the policy changes that we had recommended. And because those came in more linear, we were able to deal with them. There were smaller spikes at the end of the week, and so it made it easier to react to that within the warehouse. So, what are the results that we got? The first big one was cycle time. So, we had a big focus on from the time when the order was downloaded to the warehouse until it left, how long was it spending in the warehouse? And as we delivered these results, you could see this was before in orange, this was after in green. You could see a reduction, significant reduction as we moved to the new process. And one of the benefits, I mentioned the inventory holding that was happening on the customer side if we shipped early to them. We also found that if we were downloading the order into the warehouse early, it immediately locked the inventory for that customer and made it not visible to the planning system. So if we were downloading the order 7 days in advance in the warehouse, that inventory would disappear and that would send a signal to manufacturing to start building something new, even though the customer didn't need it for 7 days. So as a benefit of making things go faster, we actually had about a $500,000 reduction or a return on investment from reducing the inventory that we had on our side because we weren't using it to buffer our logistics capacity as much. On the customer side, we also had a huge benefit. The customers have a set amount of credit, right? Sort of like a credit card, a credit limit. And if they exceeded that limit, their next orders would all go on hold. And it took a lot of effort to get those orders off hold. And so by reducing the amount of time that orders were spending in the warehouse, the amount of credit that the customers were consuming actually went down, and we had significantly fewer orders that got stuck. And it was, like I said, a very manual process to get them unstuck. So we were able to actually delight our partners in sales by making the changes that we made. And then how did the overall transformation work? So our goal was to get the customers from the 90-day order pattern to something that was closer to a few days before they actually wanted it. So this line represents the percentage of orders that were within the target lead time that we had. I believe it was about 2 weeks. And so you could see not a lot of orders within 2 weeks. And as we made the change, we started to see a lot more orders within 2 weeks. And actually, eventually, after this, it went above the target amount. And so that meant that we achieved what we wanted to. We changed the behavior of our customers, and they adopted the new pattern that we wanted. So, what did this look like from the customer side? Well, it was really important on-time delivery. We kept that same or better. The quality to the customer. So we were doing things faster. It's then possible that you deliver the wrong quantity of product, or that you don't package it to their specification, or you put the wrong label and it goes, this customer to this customer. Those are really bad quality issues that are difficult to resolve. We found that we were able to keep those same or better as they were before. And operating expense. That was the big conflict that we had at the beginning. we were able to implement these changes with basically the same installed capacity that we had in place, with the exception that when we went live, there we had to have a little bit of trust and negotiation with our operations partners. So we allowed for some extra overtime. We made sure that we had additional labor available at the beginning when we made the change, but very rapidly they saw that it was working and they were able to eliminate those spikes in operating expense, and we were able to keep the costs down while increasing the speed significantly. Last thing was the customer feedback, and we went to our customers and asked, "Hey, this is an industry trend. This is something that you're asking for. How are we doing?" And a few months after doing this, we confirmed that we still had happy cats. So even one customer said that we had gone from worst to best with the delivery of this. So that was really an excellent outcome and what we hope to achieve with the overall transformation that we were doing. So let me talk briefly about lessons learned, then open it up for questions. I talked about on that one slide, policy change is greater than physical change. So before you go and spend money on new technology, new capacity, more labor, more hiring, those may be the solutions that you need. You certainly can't policy your way out of a significant growth ramp of a company or a major technology shift or new products that are coming out. The company's going to have to spend money, but there are a lot of ways that you can examine the rules that you've put in place and realize that the rules that made you successful up until now, as the overall business environment changes, those rules may not suit the new business environment in the same way. And so you should be very open to challenging the rules and the policies that you had in place before you go and just keep adding capacity to the way that you do business today. So that was a big learning that we had, and something that helped us to make better decisions in the future as well. The second is, as an engineer, you need to act like an owner. You need to understand the business impact. What is important to the customers? How does the company make money? And how will your spending money benefit the company now and in the future in their goal of what they're trying to do? And this is really about systems thinking, and I won't go too deep. I'll touch on it in a reading recommendation, but this is about optimizing the entire company versus optimizing just one part. And in this case, we had to have that discussion. If the customers want this in order to grow our revenue, then we may need to sub-optimize either the cost or different aspects of the warehouse. We were able to do it without making major trade-offs, but if you need to make a trade-off locally, you want to look at what are you really trying to do as a company and ensure that you're not just optimizing your part of the process. To help with that, you really need to be curious and expand the size of your system. So I started in the logistics organization. I was really focused on optimizing logistics. And at the beginning, that was about cost and efficiency. And as I grew to understand how the business made money and the role that logistics played in that, my recommendation shifted towards looking at how we could actually optimize other aspects of the supply chain, and which kind of goes back to this global versus local. So by not optimizing logistics, we were able to increase overall revenue, which was very positive based on the gross margins that the company was getting. And so, you really want to focus on what you can control, but over time grow what your system looks like and how much you understand about the overall company that you work for. And very important to go to the GEMBA. This is a lean term, and it basically means where the work is actually performed. So as we looked at our solutions, we went and we observed what was going on the warehouse floor. We sat with the warehouse planners and we looked at how they did their work. And most importantly, we went deep into SAP and we found the hard-coded elements, the tables, and the parameters that were set. So we really understood uh, how those worked and what the impact was of changing those. So those are different examples of going to where the work is actually performed. And lastly, a few examples, a few charts that I put out there. We used many, many more in this case study and many, many more throughout my career. Get the data and make it visual. Look at it in different ways. A timeline is especially good. Grouping things by day, location, category helps you to find patterns that are causing the problems and lead to really effective solutions, and also helps your partners and your management to understand what the problems are and how you're trying to solve them. So I hope that case study made sense. I hope these lessons learned are useful for you, and I'll open it up to some questions. Dr. Mahoney, are you there?
All right. Sorry, I'm in the
Okay, there
library.
you
It's a
are.
little noisy behind me. Okay. Looks like we do have a question in the chat from Kevin.
Do you want me to read it out?
Yeah, hold on. There it
Oh
is.
yeah. Which job titles did I have while working on this case study? So this in this case, I was a technical program manager. So this is actually the project that moved me from I had been living and working in Phoenix, Arizona, and the biggest challenges that we had were with our distribution in Europe. And so to execute this project and lead it, I moved from Phoenix to Amsterdam and ended up staying once this project was done. But this was basically representing the logistics group as a technical program manager, and then ensuring that all of the policy capacity changes that we put in place were executed, which is part of the program management perspective. But it's labeled as technical program management because often program managers don't need to have expertise on the domain that they're transforming, right? Or the changes that they're driving. They're managing the resources. They may be managing technical resources. I found it was a good combination, and in some of these more technical projects to bring together those two skill sets of engineering and program management to have a deep understanding, and eventually that grew into what became the architect role, right? Of having an overview of how all the pieces come together. What are we trying to achieve, and driving the team to achieve specific results, and mentoring and coaching the team on what technical solutions could help us to get there. Having a deeper technical expertise in the area helped in all of the programs that I did during that part of my career. How long did it take to implement all of the changes? Thanks, Keegan, for your question. So I think in this one, this took about a year. So at the beginning, or when I arrived, we hadn't decided exactly to what extent we were going to implement changes or what that would look like in the sales system or the planning system. So we probably spent about the first 6 months trying to understand the overall transformation that I described. What were we going to offer for customers? How would the overall supply chain transform? And so I was able to participate in those discussions, sort of put guardrails in place about, hey, if we go down to 0 days with our customers, that's really going to have a negative impact on our overall performance and cost. And make sure that the overall design of what we were trying to do when it went in a positive direction. And then we had about 6 months to go assess, look at our capacity. And it wasn't just in one warehouse. We had about 25 different factory or warehouse codes worldwide. We had to look at all of them, figure out their baselines, what the specific change meant for them, and then go execute these changes when they went and offered this to the customer. So it was a little bit more than a year to characterize the problem, follow the changes that they were going to make in SAP in their domains, and then respond to that within logistics. All right. Another question from Lainey. Thanks. How did I encourage the team to embrace the changes you made? Uh, yeah, yeah. It's when there's a change, people don't like it, and it's hard to get them on board. Um, in general, true. One of my idols, and when I show my recommended reading, my number one, Dr. Ellie Goldratt. I once got to meet him at Thunderbird University, and he started his discussion, and he said, "People are opposed to change." And everyone nodded. Yes, of course, we've observed that. We had all been working in industry for a few years. And then he said, "Who here would like $10,000?" And everyone raised their hand. And he said, "See, change isn't that tough." So obviously, that's an example where people immediately feel that the change is going to be positive for them. That's among the easiest examples to sell. But I think the approach that I took, and like I said, becoming a warehouse manager really helped me to understand the their what their concerns were in a much more visceral way. But just having an open and transparent discussion and asking your partners, what will it take for this to be successful? So as part of this, as part of the changes, I mentioned uh, that we put in place a fixed lead time, right? And our sales partners were not very happy. They really just wanted to go to 0 days and tell customers, whenever you want to order, you place an order, but they understood that was a challenge. And so we told them we would put in place, or we sat down with them and we said, what would it take for this to work for you? Right. And so we really listened to them up front and elicited what would your requirements be to go along with the change that we're recommending. And they gave us a pretty long list of requirements of how it would need to work. And as we designed our solution, we went through one by one to address their concerns and be able to come back. And in that specific case, for that aspect of the policy change, when we came back, I went through the list and I said, "Hey, when we met a few months ago, this is what you said it would take, and here's what we're delivering." And that was one example where they just said, "Okay, we said we'd agree if you could do those things." Really, we didn't think that it could be done, right? There were a few technical hurdles that we had to figure out how to do in SAP, but they said, "Hey, you met the needs, you understood what it took for this to be successful, and we're willing to take a risk and pilot this and go with you to the next step." So that probably number one is understand their concerns and assure them that you're going to address their concerns. Now, that doesn't mean you're going to solve them exactly the way that they want, but that you're going to not ignore them and address them. That builds trust from the beginning. And what I just mentioned, piloting, start small, right? So can we take a subset of the business, a small location, a smaller set of products, and run this process and see how it works without putting the entire enterprise at risk? And as fast as you can get to those proof of concept, pilot, those are things that build a lot of confidence and then give your partners the ability to say yes when you need to make a change. But you know, it's never easy, but it's also important to discuss what's out of your control, right? The business environment was changing. The industry was expecting faster lead times. And so we could figure out solutions together, or we could see the market share of Intel erode because we didn't meet the needs of the customers. And so when you talk about the higher level objectives, where do you have shared objectives? Try to find those and say, hey, we're trying to achieve the same thing. We may need to approach it in different ways, but we really are trying to get to the same place. So those are a few ways that I'd like to address change.
All right. Do you want to go to you have a couple book recs. I know some students probably have to go around 3:15,
Oh
so
yeah,
you can kind of
yeah.
get those
Let
out.
me
And then
let me.
I imagine you'll stick around for a little bit if there's still some.
I will. I will. Happy to answer any additional questions. So I mentioned this one, Dr. Ellie Goldratt. I read this book. This book was handed to me, or actually emailed a recommendation to go buy it before I started my internship at Schlage Lock, and one of the most beneficial and powerful things that a manager could have done for me. This book and the theory of constraints methodology is something that I have studied, put into practice, studied more, failed some, succeeded some, and continue to work on. It's something that has really benefited me, and that the idea of focusing on the global optimization and focusing on the flow and not just trying to optimize for cost are things that are really discussed in that book. So highly recommend that method, and the goal is a great starting point for that. The other two are less technical. So this Getting Things Done, or GTD, by David Allen, this is something that basically talks about how do you manage the constant flow of information and requests that are coming at you. And I'm sure they're challenging in a school environment. I remember that they were. It gets more challenging in a corporate environment, right? Just the number of channels of Teams, Slack, email, people coming into your cubicle, phone calls. Uh, there's a lot of things coming at you, and I found that GTD is an excellent discipline to help manage that flow, get it organized, and be able to operate in that environment. So definitely recommend that, regardless of what discipline of engineering you're in. And then the last one, Predictably Irrational, by Dan Ariely. Not a typical engineering book, but this book talks about behavioral economics, and what behavioral economics is how do people actually respond to different situations. And so, just as a quick example, I mentioned, do you go to the customers and offer them 0 day with the risk that you have to go back and have a 3 day lead time? Or do you start with a 3 day lead time and go down to zero? And there's a concept he talks about in there called loss aversion. And it basically says that once you have something, you value it more than it really is worth, right? And giving it up is very painful. And so if we offered a service that we couldn't deliver and then backed out, that was going to lead to a lot of negative emotion from the customers, which could impact their loyalty and the revenue that we got, versus starting with a more realistic approach, which may not delight them as much, but the effect on their behaviors would be less than if we disappointed them. And there's a bunch of interesting concepts in there that I have found to be very useful. The question about change, it's something that I think about in how I package my offers, what I'm trying to influence, in order to avoid certain traps and triggers that could prevent people from being open to change. So that's a book I recommend on that topic. And I think that's what I got. I really want to thank everybody for your attention, your questions. I hope you found it useful. If you have more questions, I'm going to stick around for a bit, and I thank you very much for the opportunity to present to you today.